Let's work through an example of using the Black-Scholes model to value an option. Here we've got the formula for a call option. The value of a call option is the share price times the normal distribution density of something called D1 minus the exercise price times e to the minus rt, where e is the exponential, times the normal distribution density of D2. D1 is the natural log of the share price divided by the exercise price plus the rate of return plus half of the standard deviation squared multiplied by the time period divided by the standard deviation multiplied by the root of the time period. And D2 is D1 minus the standard deviation multiplied by the root of the time period. So here's an example. A project has a net present value of -5. There is an option to follow on in 4 years' time when an investment of 200 million would be needed. The cash flows for this project are 125 million in 4 years' time. The standard deviation of returns is 30%. The market return is 6% and the hurdle rate is 11%. So what's this option worth? Well, this is a call option because what you're being asked to do in 4 years' time is to consider spending 200 million. So 200 million is going to be the exercise price. The time period is 4 years. The share price is, well, what would this project be worth today? Well, it's going to be worth 125 in 4 years' time. This is a project, so we'll look at the project risk. So we'll discount this to today using the hurdle, 1.11 4 years' time to the power 4. Standard deviation is 30%, risk-free rate is 6%, etc., etc. So D1 is the log of the share price, which we've calculated to be 82, divided by the exercise price, 200, plus R, which is 6%, plus 30% squared divided by 2, and multiply that by 4, and divide that by 30% multiplied by root 4. And that comes out at minus 0.779. D2 then is that minus 0.779 minus 30% of root 4 multiplied by root 4, which is minus 1.379. Here's our formula for the call option, and what I've done here in green is to show you how I calculate these normal distribution densities using the Excel command normdist. So the first figure you put in is the number D1 or D2, whatever it is, and then you have to put 0, 1, 0 to get the right figure. So you do that, you get these figures at the bottom. You just need to be really careful to calculate all these correctly, and you end up with a value for this option of 4.74 million. The net present value for this project was -5, so the value of the real option still doesn't make the project viable. It would still be negative, so you wouldn't invest.